Here in this clip, we'll look at an example of when one way of setting up a region is better than another way. Okay, so suppose we're looking at the region which is bounded by these two parabolas, 3x squared and 4 minus x squared, and it's also bounded by the y-axis. So we're looking at this region right here, and we want to integrate some function over this region. So this symbol right here means we want the double integral of x squared y over this region D, and we don't care how you do it. So you could do your dx, or actually you could do the dy integration first, or you could do the dx integration first. All right, so I want you to figure out on your own, take a guess, which way is going to be the better way to set this sucker up. Pause the video for a second, maybe write something down, think about it, and come up with an answer. Which one do you think is going to be better? All right, ready to proceed? Okay, let's see. So if we're doing the dy integration first, then that means that we're going to be starting our integration somewhere on this curve right here, and we'll be going vertically up, starting here and ending here, and so we're ending on this one. Okay, so in other words, we're going to be going from we're going to start at y1, because that's y1, and we're going to stop at y2, and y2 is 4 minus x squared. Okay, and then we'll do that. Where do these blue slices begin? Well, the first blue slice is right here at x equals 0, and then the last blue slice is right here at something. Well, how do I figure out where this point is? Well, that's going to be the intersection of the curve y equal 3x squared and the curve y equals 4 minus x squared. And so the point in the intersection is going to be given by the xy coordinates that satisfy both of those equations simultaneously. All right, well then, since each of these is equal to y, they're equal to each other. So I've got 3x squared equals 4 minus x squared, and I add the x squared to both sides, and I have x squared equals 1, and since x is not equal to minus 1 based on the picture, this has to be x equals 1. Okay, so then that tells me that this one right here at x equals 1 is going to be the final slice. All right, so I have this set up now. We're going, x goes from 0 to 1, y goes, actually, yeah, let me write my little subnotations. X equals 0 to x equals 1 of, and we've got from y goes from, what was the green, 3x squared up to y equals 4 minus x squared y dy first, followed by dx. All right, so that was the first one. Now let's look at the other one. And so we're going from left to right. So we're going to be looking at slices that go across like this. So they're going to be first hitting here and then hitting here. So we're going to be starting on this curve, and then we're going to be stopping on this curve right here. And then you realize something terrible is going on, right? So our ending curve doesn't have a nice unique formula. Instead, we're going to have to split it right here, and we will have two ending curves. So for our beginning curve, that one at least is not so bad. That happens here where x is equal to 0, but then this ending curve right here, since we're going horizontally, we're looking at an x value, right? So this is going to be given by x equals, and then we look to, which parabola is this? Well, this is the parabola y equals 4 minus x squared, but now we want this in terms of x. So we have to solve this, and it turns out to be square root of 4 minus y. Meanwhile, down here, we have the bounding curve of x equals, and now we look at the other parabola, which was y equals 3x squared, and so we see that this is going to be the square root of y over 3. So, what's really going on? This region is not an elementary region. There are two elementary regions, one of which is this one down here. That will be one integral. And then the other one is going to be this part up here. That will be some other integral. Okay, so for the first integral, we are going to have, let's see, so we're going to go from 0 up to 3. This is y equals 3 right here. We're going to go from 0 up to 3, and we're going to go across from 0 to square root of y over 3, x squared y dy, dx dy. So that'll give me, so this one here corresponds to this lower region. And then we'll have the rest, so that only took us up to 3, so then we go the rest of the way from 3 up to 4 of, and this is from 0 up to the other parabola, square root of 4 minus y, x squared y dx dy. And so then that one will be the upper integral up here. And so this identity that I've written right here, this is true. These are equal to each other, but you can see that this one is starting to look a lot more preferable to this one over here. Not only does this one have two integrals to evaluate, but the functions involved are uglier, right? Who wants to mess with a square root when you can possibly avoid it? So we elect to evaluate this using the first integral. So doing the interior integral first, or the inside one first, this is going to be, let's see. Oh, and by the way, notice that the integrand did not change, right? It's the same integrand no matter which way you set it up. Okay, and so x squared y. When we're doing the y integration first, x squared's a constant, so we just ignore it, basically. And we integrate the y to get y squared over 2 and evaluate it from 3x squared. And let me emphasize, this is for y equals 3x squared up to y equals 4 minus x squared dx. And so this is telling you what exactly you're going to substitute in for which variable. And again, that's important to keep in mind because we're going to be doing triple integrals later on, and you want to keep track of what you're subbing into which. So this is going to be, let's see, 0 to 1, x squared. And so then we have, actually, let's take that. Yeah, okay, this is fine. So we have 4 minus x squared quantity squared substituted in for y, minus 3x squared substituted in for y, all divided by 2 because it was y over 2 dx. And okay, so let's get the 1/2 out of there because it's just cluttering up that whole biscuit. And if we multiply out all the stuff, distribute and everything, then we end up with, let's see, 8x squared minus 4x to the 4th minus 4x to the 6th after some messing around on the scratch paper. And then this turns out to give us 8/3 minus 4/5 minus 4/7, which if you put it all over the same gory common denominator of 105 gives you 136 over 105. All right, it ain't pretty, but it's an answer.